Hello everyone. In this lecture, we are going to learn about some basic concepts that will be used throughout this video series. An electric circuit is an interconnection of electrical elements used to accomplish specific tasks. The diagram shows a simple circuit made up of a battery, a switch, a light bulb, and some conducting wires. The circuit has two goals. One is to provide electricity to a light bulb and the other is to switch it on and off. SI units and its prefixes are used in engineering to communicate. In the table, we have 6 basic units which can be used to derive all quantity units. For example, the Hertz unit for frequency is the inverse of the time unit. SI units also make use of prefixes to relate numbers large and small. Using the table, we can find out that 1 meter is equal 1000 millimeters and 0.001 kilometers. Another basic concept is charge. Charge is an electrical property of an atomic particle. It is measured in coulombs. 1 coulomb of charge is equal 6.24 times 10 raised to the power of 18 electrons. Charge can neither be created nor destroyed, it can only be transferred. Electric charge is mobile. The flow of this charge produces current. When a battery is connected to a connecting wire, charge will flow through it. Electric current is the rate of change of charge per time. Finding the derivative of charge will give the current. To add to that, integrating both sides will give the charge. Current is measured in amperes. 1 ampere is equal 1 coulomb per joule. Current comes in 2 forms. Direct current DC and alternating current AC. Direct current is when current remains the same as time passes. 5 amperes after 10 minutes will still be 5 amperes. Alternating current changes periodically with time. It is used in households to run electric appliances. Next is voltage. Voltage or potential difference is the energy required to move a unit charge through an element. Voltage is the rate of change of energy per charge. It is as shown in the equation. Voltage is measured in volts, which is equivalent to joules per coulombs. Depending on the polarity of an circuit element and the direction of the current flowing through it, voltage through an element can be positive or negative. The voltage from A to B in the figure to the left is 6 while the voltage to the right is -6. To note, in this diagram, the circuit can either have a negative or positive voltage or a negative or positive current. Another basic concept is power. As shown in the formula, power is the rate of change of energy with time. If we expand on that, the power equation turns into the product of voltage and current. Power is measured in watts. All power in an electric circuit equates to 0. Meaning that the power absorbed plus the power supplied is equal to 0. Depending on the voltage polarity and the current direction, power can either be positive or negative. The figure to the left shows that the element is absorbing 12 watts of power while the figure to the right shows the element supplying 12 watts of power. If you integrate the power equation, you will get energy. Energy, it is the capacity to do work and it is measured in joules. Elements in a circuit can either be passive or active. Active elements like generators and batteries are capable of generating energy while passive elements like resistors, inductors and capacitors are not. The most important type of active elements are voltage and current sources. They are 2 types of sources, the ideal independent sources and the ideal dependent sources. Ideal independent sources are sources that provide specific values of voltage or current independent of other circuit element. Ideal dependent sources are sources where the values are controlled by the voltage or current of other circuit element. The sources can either be a voltage-controlled voltage source, a current-controlled voltage source, a voltage-controlled current source and/or a current-controlled current source. Also to note, most dependent sources in a circuit diagram are diamond shape. Here's an example. Calculate the power supplied or absorbed by each element in the circuit. Try pausing it and attempting it by yourself. Here we have two loads, a dependent source and an independent source. Remember, the polarity matters. If the current enters the element from the negative side, the current value is negative. Using that and the power formula, we are able to find the power values of each element. If the power value is positive, the element absorbs power, and if the value it is negative, the element supplies power. To verify your answer, check if all the power found adds up to 0. In this example, we will transform units using prefix multipliers. The question is to express 2 megavolts as kilovolts. Pause it and try it out. From the previous table, we know that 1 megavolt equals 10 raised to the power of 6 volts. And 1 kilovolt equals 10 raised to the power of 3 volts. So to solve, we will change the voltage to volts then to kilovolts by manipulating the units. See how the units cancel out to leave only kilovolts standing. 2 megavolts will yield 2000 kilovolts. With that comes an end to this lecture. Thank you for listening. Hope you understand. Stay tuned for the next one. Later.